This presentation is on vertical farming. My name is Olua Jackson. Conventional agriculture consumes up to 85% of the world's freshwater resources. This is a huge amount of water consumed, and vertical farming could be the solution. Vertical farming only uses 8% of the water to get 20 times the yield of conventional soil farming, and there's no polluted irrigation runoff to contaminate waterways and streams. On top of that, indoor agriculture is impervious to climate change and adverse weather events that could otherwise ruin crops. Additionally, vertical farming uses 90% less land than conventional agriculture, and it reduces the fossil fuel consumption from farm machinery. Cities can produce food locally by growing in buildings, and conventional farms can be allowed to revert to natural ecosystems when they're replaced by urban vertical farms. Hydroponics is one of the systems that is often used with vertical farming. It allows plants to mature faster because hydroponics doesn't require plants to develop a taproot that extends deep into the soil to extract soil moisture and nutrients. Instead, plants are grown in oxygenated water that's infused with nutrients in an inert medium, such as gravel or styrofoam. Hydroponics produces as much as 30% more output than soil-grown plants. And there are disadvantages. One of them is that the nutrient solution and the pH of the water must be controlled carefully. So there is a lot of monitoring that is required for hydroponics. This system is also more expensive than soil agriculture. And since water is heavy, the floors of buildings need reinforcement to hold up all the weight. Also, this system is vulnerable to pump failures, and in this situation, oxygen is no longer getting to the plant's roots, and so they will actually suffocate. Aeroponics is even more advanced. In this system, roots are immersed in a nutrient-laden mist environment, so no soil or medium needs to be used. The vertical arrangement of the plants assists gravity-fed mist distribution of water and nutrients. So it basically falls down past the roots from the top of the installation. And aeroponics uses 95% less water than conventional cultivation, with faster growth. Water and nutrients can be recycled. Unfortunately, equipment malfunctions can quickly kill plants, because if there's no mist falling over the roots, the plants quickly dry up and die. Also, this system requires energy-intensive lights and pumps. Indoor farming allows a higher yield in a limited area because it stacks rows of plants on top of each other, unlike conventional soil-based agriculture. Also, growing conditions can be optimized and customized. No pesticides or weeding are required, so this is a very efficient way to grow organic crops with highly nutritious results because nutrients can be customized, and it's good for growing biopharmaceuticals. Lighting is a key area in indoor agriculture, and since lighting is artificial, it doesn't need to replicate sunlight, which is mostly yellow light. Plants don't actually need yellow light. They tend to more rely on blue light and red light. Plants need red light for their flowering stage and blue light for bushy growth, and you can customize which light frequencies you shine on your plants to determine how they'll grow and the timing of their flowering. It makes farming inside buildings or shipping containers possible, and it's also more cost-effective now because of the development of LED bulbs, which are both long-lasting and price-efficient for the amount of light they put out and for how long they last. Also, LEDs produce little heat, so they can be kept near plants, and stacks of plants can be stacked closer together. On the other hand, HID lights are good for dense foliage because they provide better light penetration into the leaves. Fluorescent lights are good for seed starts, but this lighting type is inadequate for fruiting crops. Aquaponics is a very valuable system because it replicates the natural ecosystem in that plants and animals work together and nourish each other. So, aquaponics is aquaculture, which is the cultivation of fish or crustaceans, combined with gardening, which is growing plants. So, the fish waste fertilizes the plants, and then the plants' roots clean the water for the fish in a cycle just like a natural ecosystem. And since they can achieve an equilibrium with each other, once that equilibrium is achieved, aquaponics requires less water monitoring than hydroponics does. And it's less expensive to feed fish than it is to buy man-made plant nutrients for hydroponics. The recirculated water never needs to be discharged, just topped off, whereas in hydroponics sometimes the water gets too filled with salts or has other issues that require some of it to be replaced. Urban agriculture will allow us to shrink the carbon footprint from food transportation by growing crops locally right in our cities. And this will allow us to make productive use of our brownfields, our abandoned lots, abandoned buildings, and of our buildings' roofs, walls, and balconies for growing food. Modular farms are possible, and these use portable shipping containers so they can be moved from place to place or added to and subtracted to as demand dictates. Also, this reduces the impact of industrial agriculture on rural land, and it can be done year-round, so you can get multiple crops per year, not just one or two, with air, water, nutrients, and lights all precision customized to the needs of the particular crop. Growing plants in our cities will help eliminate urban food deserts, which are places where it's difficult to buy fresh vegetables and produce within walking distance. Living walls are also a great innovation, and in this situation, urban spaces are made more beautiful and productive by growing plants and structures that are held slightly away from the building surface, so the plants aren't actually growing out of the wall of the building, like for, say, example, climbing ivy. It's actually a structure that the plants are planted in, and the vegetation is valuable for protecting the building from UV light, from rainstorms, from temperature fluctuations. It provides a sort of insulating layer. And inside buildings, the vegetation filters out air pollutants and gives off oxygen, which makes the building more healthy for the occupants. Tropical plants can be grown on interior walls because these spaces are kept warm, whereas for exterior walls, plants from one climate zone colder than the actual location are to be preferred. Now, one question people have about indoor gardening and vertical farming is, what about the energy use intensity? Is this actually better for climate change or worse for climate change? What are the climate change impacts of using energy for grow lights and for pumps? Well, a researcher named Malik Al-Chalabi found that in many arrangements, there's enough energy generated from solar panels to support food production within buildings on site. And so green energy production can make vertical farming more climate friendly. So in conclusion, I would like to say that vertical farming can reduce water use, land use, degradation of the soil, fertilizer runoff into waterways, which causes dead zones and kills aquatic life, and other ecosystem impacts, such as cutting down forests, while growing abundant, healthy, local, organic, and sustainable food for the urban dwellers, which are expected to be 70% of the population by the year 2050. And this can offset issues relating to agriculture from coming climate changes. Thank you for listening to my presentation.